Welcome to Lecture 6, where we discuss Chapter 5, Surface Veneer Sedimentary Rocks. Lecture 5 is divided into 3 parts. First, where we discuss weathering and erosion. Second, we discuss sedimentary rocks, their definition, how they form, types of sedimentary rocks, and sedimentary structures. And third, we'll discuss depositional environments and soil formation. Sedimentary rocks can be introduced via a story of drilling into the earth underneath the Mediterranean Sea. In the 1970s, a drill ship discovered salt and gypsum minerals, as well as clay, sand, gravel, and shells in alternating patterns as they drilled deeper into the crust. The presence of layers of salt and gypsum tell geologists in this case and all around the world that the sea had evaporated almost completely over multiple occasions in the past. And we'll discuss why that's the case in lectures today. So drilling provides us information on sedimentary rocks and how they change in one location over time. We'll begin with a few definitions of sediments and sedimentary rocks. Sediment are defined as loose fragments of rocks or minerals present at Earth's surface, whereas sedimentary rock can be a variety of 3 different types. The first being consolidated sediment that has been cemented together. Sedimentary rock can also be material that precipitated directly from water and has hardened. Or sedimentary rock can be or form from the accumulation and alteration of planks or plankton. So for the first type of sedimentary rock, these are divided or described by the grain size or clast size. So the largest size of clasts in sediments are boulders, where these are more than 256 millimeters or 10 inches, and the smallest size is clays, which are less than 1/256th of a millimeter. So these clasts define they define all sediments and a large portion of sedimentary rocks in the first bullet point under sedimentary rocks. In the picture to the right, you see some sediment of a variety of grain or class sizes that includes as probably cobbles all the way down to pieces of silt, sand, or clay. The first step in the formation of sediments and sedimentary rocks is weathering. Weathering is the combination of processes that gradually modify and weaken rock when exposed to air and water at or just below the Earth's surface. Weathering can happen through 2 different types, a physical process or a chemical process. Most often, this is a combination of both physical and chemical processes working together at the same time. So the picture in the right shows a fresh face of granite that has just been exposed to the atmosphere as a result of a geologist hitting it with a hammer or some machine breaking off that slab, juxtaposed against faces of the same rock that have been exposed to the atmosphere for a long period of time. So the faces that have been exposed for a long period of time are weathered. See that physical and chemical processes are acting on these grains to change them, whereas the fresh face looks quite different and has yet to be weathered. Physical weathering is the breakdown of rock from physical processes. And this starts with cracks or joints forming in the rock and can occur in a variety of ways. The pictures below show some joints in a granite in California and in a rock in Acadia National Park, Maine. So we see that joints can be in a variety of directions and these directions help expose new and more surface area of rock to be weathered. There are three different types of wedging that occur as physical weathering. Frost wedging occurs when water is trapped in joints of exposed rocks and alternates between freezing and thawing. As water freezes into ice, it expands. This is an important property of water, of H2O, and that pushes the rock apart. When the ice thaws and goes back into water again, there's more space for water to intrude. Root wedging is similar but occurs when plant roots grow into joints and push them further open. So the picture on the right shows what looks like maybe Bryce Canyon National Park in Utah, where a juniper tree root has started to push a boulder off of a cliff as it's growing, and we see on the right-hand most side the result of a lot of these root wedging where the boulders have been fallen off the cliff and scattered about below. Salt wedging is a third type of physical weathering where salt water seeps into pores of rock, and as salt precipitates out of the water, this pushes out the surrounding rock or grains. Chemical weathering occurs through three different mechanisms. The first is called dissolution, where minerals in the rock break down into ions when immersed in water. So what we see here is the water molecules interacting with the crystal surface on the right and the crystal surface starting to attach to those ions in the water, leaving a weathered surface behind. This is most common in limestones, or this occurs in many rocks, but is best exemplified in limestones, where water that is slightly acidic coming from rain hits the ground or enters into the ground and dissolves some of the rocks. This is the reason why limestones are so holy, they have so many holes in them, and is the reason for the unique geology near the surface in north central Florida, made up of lots of springs and swallets and sinkholes. Hydrolysis is reactions with water that break down minerals and form new minerals. One example of this is the production of clay, as feldspars and other aluminum-rich minerals break down and interact with water. A third type of chemical weathering is oxidation, where reactions of iron-bearing minerals interact with oxygen and form rust. Here is an illustration of physical and chemical weathering working together. As physical weathering opens cracks or joints in the rock, the higher exposed surface area allows for more rapid chemical weathering. So we start with the intact rock, and the rocks break as the surface area allows more chemical weathering to happen faster. Eventually, we result in sediment being created, lots of quartz and clay that over time gets washed away, and as the clay gets washed away, tumbling quartz grains get washed away also and become rounder. Differential weathering is the phenomena that occurs when rocks weather at different rates based on variations in their compositions or the number of joints. One example, pictured below, is that a shale is a much weaker rock than a sandstone at Earth's surface. It's not cemented as well, and the bonds between grains aren't as strong, so it weathers away more rapidly than the sandstone. In these types of rocks that alternate, and these types of outcrops or cliffs that alternate between rock types, we often see sandstones forming cliffs and shales forming valleys or indentions in the rock. As weathering happens, the corners and edges of rocks and individual grains become more rounded, as seen in the picture below. This is how we get very rounded quartz sand grains at beaches after long periods of weathering and erosion.